So one sensor that works in a similar way to your light sensor, there's actually two of them. I'm going to go back to stop sharing, come back to this so that you can see what I'm holding up. This is your moisture sensor. And I know that not all of you probably have it, but there's a screw terminal here on these that requires a tiny, tiny screwdriver, like a eyeglasses screwdriver, or I don't want to tell you to do it, but maybe the end of a steak knife type thing would work. But if you look at the back, so we print what each pin on boards are supposed to be. We label them, and it's called screen printing. And if you look at it, one says SIG, one says GUND or ground, and one says VCC. VCC stands for voltage, basically, your power. So when we look at your light sensor circuit, the wire that goes to ground would go to ground, the middle pin here. The one that's signal, which would be the one that goes to A0, would go to the SIG pin here on the screw terminals. And then VCC is the one that goes to 5 volts. I'm actually going to show overhead, and I have a small screwdriver, and so I'll replace it on mine so that you can see how this works. So I'm going to remove the 3 wires for my light sensor. I'm actually going to remove everything from the light sensor. And I have the moisture sensor here, and I'm going to open up the screw terminal quickly. Lefty loosey, righty tighty. And I'm going to find my ground first, which is this wire. Goes in the middle. So I insert it into the screw terminal. Hold it in place while I tighten it down. And then I flip it back over. VCC is on the left, so that's my 5-volt line. Put that there. And then the last one is A0, or signal, which will go in the last one on my right. Perfect. So now, I don't have any coffee left in my coffee cup. If I go back to, I'm actually going to share my serial monitor again. It says 0 all the way across the board. And then as I come in contact with it, or close that circuit, I'm now at 700, I'm just touching it, right? Holding my finger across, and it's now at 726, 723. Trying to see. I don't have any coffee left in my, oops. I don't have any coffee left in my coffee mug, otherwise I would drop it in there and see what happens. I'm not going to put it in my mouth either. And I would recommend not to do that. So again, when you have moisture in the soil, so if I stuck this in the ground and there was moisture in the soil, you're going to get a large number. And if it was completely dry, you'd get a really small number. And if it was outside of the soil, you'd get 0. The circuit's not even completed at all. So we now have a sensor that has value to it, an analog value. One of the things that we can do with analog values is go back to my code. Close my serial monitor. Is that we can do some logic with that value, greater than, less than type work. And we do that with, has its own structure. So again, I'm inside a void loop. So sometimes when we start writing if else statements or if statements, it gets really messy with all of the curly brackets or braces. So one of the things is I'm always staying inside of that void loop or void setup. I'm not going outside of it. I'm going to say if, and then open closed parentheses, and then a set of curly brackets. So if, and then inside of parentheses, and this is where we would play Simon Says, by the way, as a group, but we can't. So if, and inside of these parentheses, we're going to put a true, false, or Boolean statement. So if val is less than, I don't know, 600, let's say, do something. And if that statement is true, it's going to do whatever's inside of those curly brackets. We're going to have it blink. So I'm actually going to cut and paste this code inside of my if statement. Instead of val, I'm going to put 1000 here. I'm just reusing a bunch of my code and just moving it around. So if val's less than 6000 or 600, blink like we were like those railroad crossing. Outside of my if statement, I'm going to put else, and then just a set of curly brackets again. So if val's less than 600, on off, blink, blinkety, 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 else we're going to say digital write 13 low and digital write 11 low. So if it's greater than 600, it'll just be off. Higher or less than 600, emergency blinking alarm. Make sense to everybody? Cool. Okay, I'm compiling my sketch. And so now, if you look at my overhead shot here, it's blinking. And then if I close this circuit, hopefully it goes over 600. It stops. And then if it gets dry, the blinking alarm goes off, letting me know it needs to be watered. And if I water it and it gets damp, it turns off. So right here, we've created kind of a reminder alarm for those house plants that tend to dry out a lot. Anybody have any, I'm going to pause. Does anybody have any questions that they want answered by me? General questions that might be good for everybody? You can go ahead and ask them in the chat. We'll pause here for a little bit. Going once. Oh. Yes, there's a recording of it, Simon. Oh. That's a question I don't know. Jan will answer that one for you, I think, or come out through an email. So one of the things that we're going to do is everybody get out their servo motor. It looks like this. It's the black thing. Yours doesn't have a hub on it yet, but you can, there's a little Ziploc baggie that has a bunch of different shapes of horns. So feel free to grab one if you're looking for it. And this has 3 wires to it. Red, a black, and a white. So black is going to be ground, red will be power, and white will be signal. And servo motors are really powerful, but they're also really finicky. We have to do some extra programming to use them in terms of bringing in what's called a library. And we're going to do that in a second. But first, we need to kind of hack the end of this servo. As you can see, these are female end, and I can't attach it. So I need to actually add some wires to it. So I'm actually going to peel off 3 wires. And I have a black, a gray, and a white in my hand. I know that it's hard to see. But I'm going to add the black so that it lines up with black. I'm going to add plug in the white to white and gray to red. This one. So now I have 3 wires hanging off the end of my servo. What we're going to do is we're going to plug in, oh, sorry. It should be on my, if you can see my overhead shot as well, but I will stop sharing. You should be able to see the overhead view. So I've taken 2 wires, or 3 wires, and I've plugged them into the end of the servo. And I at least match up the black, and then there's a gray to the red and a white to white. And those are ground, power, and signal. I'm going to plug in the black, which is ground, into the ground rail of my breadboard. And I'm going to plug in the signal wire into pin 9. Sorry, I'm actually going to take my moisture sensor. No, we're not. We're going to leave it. Just move it out of the way. Take my signal wire. I'm going to plug it into pin 9. I'm going to leave my power, my red wire, loose until we get code on our Arduino. And we're doing that because once we power up the servo, our signal line is very sensitive. So if I have too much voltage or current on that signal line, and it can actually damage the servo. So we're going to wait until we get within safe parameters on that pin before we go and plugging things in. So I'm leaving my servo unplugged for now. I'm actually going to show a fritzing drawing here in a second. I'm going to go share here. I'm going to pull in a servo motor. And I have my black connected to black. On this servo, there's yellow and red, but the yellow is connected to pin 9. And I have not plugged red into anything yet. I'm going to leave it hanging there. Okay, to the code. To the code. Screen share. We're going to go back to our original program. And we're going to do something called importing a library. So we're going to go sketch, include library. And these are all of the libraries that you have to choose from in terms of external hardware to use. I have more than you do because I use a lot of different libraries, but you're looking for servo. So, and it puts at the very top, it puts this pound include, and then inside of chevron, some servo.h thing, and just stays there. So I know that we always said, I said we never put things outside of void setup and void loop. Rules are meant to be broken. That's what we're doing. So again, this is, I'm going to put in the chat, it's sketch, include library, servo. Yep, okay. So once we've included the servo, we actually have to then create a servo object. So we go to servo, we're going to call it my servo. So we've created this object. So we're saying, hey, this thing called my servo is a unique thing of servo. Just like my name is Derek and I'm unique, but I'm a member of the human race. Some people would beg to differ, but that's different. And inside of our setup, we have to say my servo dot attach. What pin is our servo attached to? And that is pin 9. Why did I choose pin 9? If you look at your breadboard, you will notice that pin 9 has something in common with pin 11, pin 10, pin 6, 5, and 3. And that is they all have a tilde next to them. And that means they're a pulse width modulation pin or a PWM pin, meaning that we call it analog write, but we can turn them on and off super fast to emulate or simulate an analog value. So we can only attach a servo to PWM pins or those pins with tildes. So now in our if statements, we're going to write values to our servos, our servo. I'm going to say my servo dot write. And I'm going to have my servo when it's less than 600. We can give it a number between 0 and 180. So I'm going to say 10 degrees on 1. else my servo.write 170. Now, why am I not going full 0 and 180? And this is partly just knowing the hardware that you're working with. In terms of this specific servo, it can be a little sensitive, and there can be a lot of some noise in the signal, meaning that even though we're writing 170, it might interpret it, or it might show up as 185. And in that case, the servo will want to twist or turn beyond its stops and damage itself. So I always like to give it a little bit of buffer room, about 10 degrees here or there, so that we're not overexerting the servo. So if val's less than 600, the servo is going to turn to 10 degrees, else it will stay at 170 degrees. We're going to upload this code. It's compiling. So now that that code's uploaded, your servo shouldn't have moved, because we still need to hook up the power to 5 volts. Oh, which we need to actually make a jump to the power rail. So back to, I'm going to stop sharing this because we have to make an adjustment to our circuit, because I forgot to. So what I'm doing is, notice that our sensor circuit is using up the 5 volt pin. So I'm actually going to move this 5 volts to the power rail. So now I have, just like I did with the ground, I've just added 5 volts to this power rail, not the ground rail. We don't want to connect those two. That would short everything out. And then I can take my servo wire and attach it to the power. I'm going to do that now. 5 volts. Sorry for the misstep. So I'm going to stop sharing so that you can see my screen here, and that I have the soil moisture sensor hooked up, and the servo is actually kind of buzzing right now, but if I connect it, the lights go off and the servo turns. And then if I let off, lights go on, servo turns back to where it was. So maybe the servo is actually controlling a small cup or glass of water. And so when it gets dry, the alarm goes off, or when it's damp enough, it's one way, and then when it dries out, it actually self-watering. So it'll water itself, and then it'll become damp again and tip back up. So it's self-watering until it's out of water. I'm gonna So for right now, so I just unplugged my red board because I'm actually going to go through some content to help you on your way. I haven't gone through every single thing that's in your kit, but I'm going to point you at guides for helping you do those, because in terms of virtually walking through things, the more complicated circuits are going to be pretty difficult to do that real time. And so I want to make sure that we point you at a hookup guide that is, you can go through at your own pace, at your own timing. So I'm going to share out, and we'll get all of these links to you so that you have access to them as well. But before I do, I want to again pause for questions, if anybody has any. Nobody. Okay, let's go back to, oh. Yeah, I'll share that again here. So I have a wire going from 5 volts now to this red column. And then the red power wire goes to that same column so that it's passing through the breadboard. The white wire on here is yellow, but the white wire goes to pin 9. Black wire is going to ground. I'm actually going to put the soil moisture sensor back in for those of you that actually added it, so that you and then this signal. I know my wires are getting messy, but oh, I'll just use this one. There's a whole watering system or irrigation, automated irrigation system for you, desktop irrigation system.